Scarce any problem will appear more hard and difficult than that of determining the distance of the sun from the earth, very near the truth, but even this will, without much labour, be effected.
The Interplanetary Podcast. The exploration of space for the benefit of all humankind. Your hosts here in England, Matthew Russell and Chris Carney.
Oh yeah, baby, Halley. Edmund Halley. Some people say Halley. Some people say Halley. Well, how do you say it? Do you say Halley's Comet or Halley's Comet?
I say Halley's Comet. When's the last time I said it? It's been a while since I said it, but I think, I do like a shift cycle combination of the two. It depends how I feel. But it's impossible to know because nobody's alive from when he was alive, so no one knows how he pronounced it.
But people do still have the surname Halley or Haley, don't they? But
yeah,
there was no one knew how to spell then. So Edmund Halley himself used to spell his name in different ways, so you can never really tell.
Can I throw something into the mix here? How about Hawley?
Hawley as well, yeah, because it could be Hawley.
You know what I mean?
Yeah. It could be all sorts of things, couldn't it, really? But anyway, he was born on this day, 8th of November, 1656.
Ages ago.
It's really interesting. Do you know what? I hadn't actually realised just how interesting Halley's Comet, just because he was a good astronomer, but he was way more than that.
Definitely is he a Space Legend of the Week?
He is definitely Space Legend of the Week. I'm going to go with Halley as Space Legend of the Week.
Week. Brilliant.
He was the second Astronomer Royal, which is, I believe, held by Martin Rees at the moment, if I'm not mistaken. But the first one being John Flamsteed in 1720. And they knew each other. So Halley actually was influenced by Flamsteed's project of cataloguing all the stars in the Northern Hemisphere, which is pretty cool, isn't it?
Quite the task.
It's quite the task. So Halley, while he was at school, thought, well, I could do them all in the Southern Hemisphere. So he actually went to King Charles II, who basically said, yes, that sounds like a splendid idea. or yes, that sounds like a splendid idea.
You don't think that you could go down there? Yes. When will I be king? Yes. Oh.
So he basically gave him the money, and he went off to some Saint Helena, which is West Africa, and he went there and observed quite a few things, including building this celestial catalogue. But he saw the transit of Mercury, which, as I've said on a previous podcast, isn't the van that Queen used to go round in on early tours, which was also the transit of Mercury. It was when the planet transit, the planet Mercury goes across the disk of the sun. And so he saw one of those and then suddenly realised that you could use Venus, the same thing. Well, you could use the transit of Mercury, but even better if you could use Venus to... If you looked at the transit of Venus from two different places on Earth, you could determine how far it was to Venus and how far it was to the sun using just simple trigonometry.
What a genius. But can I just step in there? The transit of Venus is not to be mistaken for the tour bus of Bananarama.
Exactly, Chris. That was I feel as though that was a cover version of my joke, but it's very good.
Well, the Venus was a cover version of the Shocking Blue, so there you go.
When he got back from this monumental trip, King Charles II insisted that Oxford University gave him a master's degree, which is pretty good.
Yeah, he comes across as all right, this King Charles II.
Yeah, he's all right. He says, yes, you give this boy a master's. And but he went and visited Isaac Newton as well. That's what I love about people like this, is that they knew people like Isaac Newton. And so he went over to visit Isaac Newton because he wanted to talk about the orbit of the comet Kirch. And Isaac Newton said, "Oh yeah, no, I solved that ages ago. I've got this." And he goes, "Oh, can I see the proof?" And he goes, "No, I don't know where it is," and he'd lost it. And then he goes, "But don't worry, I'll work it out again. I'll give it to you." So he sends it over to Halley, but he calls it some ridiculous treatise on the motion of bodies in orbit or something like that. But Halley goes, "Well, this is you do realise how important this work is, don't you? This is absolutely insane." So Newton went, okay, wrote it up properly, called it Principia, and it's arguably the most influential book of all time when it comes to science. And
That's amazing.
And Halley actually paid for it.
No, he did not. That is incredible.
So Halley, is very much to blame for the rise of Newton. Halley also had a conversation with Cassini.
Oh, like you do.
Like you do. And Cassini said, yes, I think the comet is in orbit around the sun. And with this bit of information that Newton had given him, Halley was able to work out when Halley's comet, wasn't called Halley's comet at that time, would come back and revisit the Earth, what dates it would come back. And of course, it did come back on those dates, but unfortunately, Halley did not live to see it because it was 1758, a long time after Halley had died. But of course, at that point, everyone went, "Oh my God, it is back in 1758." So it became known as Halley's Comet.
Incredible. I mean, that is just what a legacy as well. It just goes on and on. And we've been lucky enough to be alive when it went over. I think I was about 8 or something.
Yeah, it's nuts. But not only that, he was drawing symbols on maps to represent trade winds and monsoons, and those symbols are used even now on modern day weather reports.
Incredible.
He was the first person to sort of say, well, solar heating is probably the cause of atmospheric, wobble and motion. He also was the first person that said, "Oh, barometric pressure probably has something to do with your height above sea level." It's like, what? These are like amazing observations.
It's absolutely brilliant, absolutely amazing.
And he was the first person to have a working model of a magnetic compass that's in a liquid-filled housing. Like a modern compass.
Yeah.
He was, that seemed to be his thing, as going around the world measuring magnetic fields. But he massively fell out with Newton and Flamsteed because he doubted the Earth's age as given by the Bible, which basically meant he lost out on loads of positions of note because, of course, we were a very religious country then.
Of course.
He also the Royal Society didn't like him very much because he suggested that Noah's flood might have been caused by a comet hitting the Earth as well. So even though that's not particularly, necessarily true, it's thinking, Halley was obviously way ahead of his time.
Yeah, definitely. I mean, questioning the Bible is definitely forward thinking.
But with ideas that are accepted in modern times as, at least feasible. And he also kind of tried to work out why the Earth has weird magnetic fields, and he's the first person to suggest that the aurora borealis had something to do with particles that were being affected by those magnetic fields.
Yeah, and at the time they were like, the people of the North were just like, "No, it is the gods. They are angry with us."
Oh no, exactly. And he worked in other fields, like he did some statistical stuff, which still is used by the government now to work out people's state pensions.
Wow!
but my favorite thing is Peter the Great, the great Russian Tsar.
Yeah,
quite liked to come to England. In fact, didn't Peter the Great spend a lot of time in Liverpool?
I don't know. I'll have to look into that. I know Hitler did.
Well, yeah, I went to art school. Apparently,
yeah.
I don't believe. There's a lot of doubt about the Hitler art. I know he applied to Liverpool Art School.
I think the art school's maybe doubtful, but he definitely had family here on Stanhope Street, about 500 meters away from where I live. Actually,
yeah. Well, I think his brother went to Liverpool Art School, and he wanted to go but couldn't get in, and then became the world's worst. Person. Because it's all thanks to Liverpool. the Second World War. But no, Peter the Great, I think he went to Liverpool, but he was over visiting England again and wanted to hang out with Newton, because Newton was really famous at this point.
Yeah.
And he wanted to hang out with Newton, but Newton went, no, I'm too busy. Halley, can you go over in my place? And Halley went over, and they got absolutely smashed on science and brandy.
What a combination.
And got arrested because Halley was pushing Peter the Great around in a wheelbarrow in Deptford.
That is amazing. The sort of 17th century equivalent of the shopping trolley.
It's so ludicrous, isn't it? It is. It's exactly what that is.
That is such a great story. I love it. The Tsar of Russia being pushed around in a wheelbarrow by Edmund Halley. I've seen it. I've heard it all now. That is absolutely amazing. Alcohol, it's a hell of a drug.
It's pretty cool, isn't it? I mean, amongst other things, he was the first person to ever take a ship out on a fully scientific voyage and things like that. So, Halley, he definitely deserves to be Space Legend of the Week. Week. Happy birthday, Edmund.
Happy birthday, mate. Have a good one.
As his particles are returned to the cosmos.
Yes.
Well, this week that's just gone, there's been the US Astronomy 10-year plan, the Astro 2020, released on 4th of November.
Yeah, exciting stuff.
It is actually quite exciting stuff because, this happens every 10 years-ish. But this is quite ambitious, this one. It looks really, really good. So it's funded by NASA, the National Science Foundation, the US Department of Energy, the US Air Force, the US National Academy of Sciences, Engineering and Medicine. So they all set out to sort of say, as astronomers, what do we want to do? What do we actually want to go out and look at? Yeah. And it starts off with this really encouraging kind of thing that's like, we live in extraordinary period of discovery in astronomy and astrophysics. 6 Nobel Prizes have been awarded over the past decade alone for discoveries based on astronomical data. Dark energy, gravitational waves, neutrinos, discovery of exoplanets, cosmology, supermassive black holes, to name them. Yeah. So that's pretty cool, isn't it? And it's like many of the ambitious scientific visions of the 2010 New World's New Horizons decadal survey, so that was the last one, have been fulfilled or are being fulfilled, and the momentum has only grown. We stand on the threshold. They're sort of nodding to your festival there, Chris.
I know, yeah.
Just new endeavours.
A little plug.
That will transform not only our understanding of the universe and the processes and physical paradigms that govern it, but also humanity's place in it.
Wonderful. Really good stuff.
It is really good stuff. It's actually a really good read because it makes you realise that these are the things in the next 10 years that we really want to know about. Yeah. And I guess that, that will be the next 10 years of this podcast, talking about some of these themes. So do you want to know what
Let's revisit in 10 years and say, 10 years ago we said this. Has it all come true?
Well, I mean, a lot of the stuff that they're talking about, they won't have even built in 10 years' time. It's like we need to get started on these monumental projects now. Yeah. Because it's going to take that long. But it's based around 3 broad themes, and these 3 broad themes are worlds and suns in context, which is obviously all about exoplanets and their observations. Yeah. And trying to find habitable planets, exoplanets, essentially, worlds and suns in context. That's one of the themes. Right. Another of the themes, and we've talked about this a lot, is new messengers and new physics. In other words, all those new ways, we used to look into space and try and see light and work out what the hell was going on in the universe. But now we've got things like gravitational waves and particles and stuff like that to look at. And so we're now probing into dark matter, dark energy, and cosmological inflation. So
that's such an important thing, isn't it? I mean, the dark matter and dark energy thing is just so essential.
Yeah, it's like, we don't know what they are. It's like, it's really embarrassing that 90% of the universe, we have no idea what it is. So that's what it's all about. It's like saying we've got these new ways, these new messengers, these new ways of looking at the new physics. So let's concentrate on that theme. And we've also got cosmic ecosystems. So that's going to link the observations of, modeling all stars, galaxies, and all the gas that's in between, and all these massive energetic processes like black holes and stuff like that, and try to couple all of that together to work out the formation of how the cosmos interacts with itself and how it evolved and where it will end up. So that's pretty cool, isn't it? So that gives the context of how they're trying to sort of work out how, where they're going to spend this I mean, when I say insane amounts of money, it is insane amounts of money that they're proposing to spend here.
Yeah.
And so it's they've got these kind of little pathways within these themes that are sort of priority areas that they want to explore. One of them being pathways to habitable worlds. So
very, very
really trying to find out if there's life on other planets or planets that we could go and live on.
Yeah,
which is that seems amazing. That's like, it seems so sci-fi, doesn't it? It seems so far away, but it's like that's what they're calling a priority.
Yeah, definitely. And we just need to know what that closest one is, because then we go, right, that's the distance we need to travel. And so this is the speed we need to go. So yeah.
Oh no, and then this other kind of pathway is new windows on the dynamic universe. So this is all about this idea of time resolved multi-wavelength electromagnetic observation. So you're trying to work out how the universe is moving and trying to work out what's happening with black holes and neutron stars, and so you can fast forward and rewind to the earliest moments of the universe.
Yeah.
And try, so it's trying to use those new messengers, I guess, and new physics to try and rewind the universe and look at this dynamic universe and how it all kind of happened. And then this other priority is the unveiling of the drivers of galaxy growth. So how did the galaxies form, basically? How did it all happen? And the upshot of this is that they kind of, back about 20 years ago or 30 years ago, when Hubble and all that lot, there was a thing called the Great Observatories.
Yeah.
And there were 4 massive space telescopes that were built because of another decadal review.
Yeah.
And that was, of course, Hubble was one of them. And Chandra was another one. Compton was another one. And Spitzer. So they built these 4 great observatories.
Yeah.
And that happened in 1990. So that it was like, that's when NASA said, right, let's build these great observatories. They're asking for a similar sort of thing this time round. So they want to build 3 enormous space observatories. The first one is going to be a bit like Hubble, but it's going to be twice as big, twice the width of Hubble's main mirror.
Right. Wow.
And it's going to be similar, and they want it to cost about 11 billion.
Ooh. Keep the budget
they want it
down.
to launch. Yeah, and they want it to launch in the 2040s. So it makes you realise, they're talking 20 years in advance here.
Yeah.
Of getting this like new great observatory up. And once they've got this one up, they want 2 more. The one that measures in X-rays and one that measures in the far infrared radiation. And they should be about 5 billion each. So they want to spend a lot of money on these big ticket great observatories in space.
Fantastic. And where does James Webb fit into
the way that James Webb fits into this really is a little bit of a warning shot, because James Webb was the thing that was recommended in the 2000 decadal survey, and it's only just about to launch, and it's massively over budget, of course.
Yeah.
The Nancy Grace Roman Space Telescope was in the 2010 decadal survey, and that's hugely over budget as well. And so it's like, one of the things in the report is, how do we stop that kind of massive overspend, which I guess, is a bit of a it's a bit embarrassing. But I think one of the things that sort of comes out is that they will probably concentrate on technology development before the project development itself. It seems. Yeah, it's an interesting read because they mention that and the kind of lessons learnt from the overruns of James Webb and Nancy Roman. So,
do you think that maybe they could have a word with the guys at HS2?
Well, it's just typical, isn't it, of big projects. I remember one of the things. I don't know whether we ever teach. We taught event management together, didn't we? And we talked about
we did. Yeah,
project slip and stuff like that. And one of those kind of interesting things is when you try and sort of say, "Oh, how long will this take?" You estimate an average, but of course, on average, more times than not, something takes longer than average, or half the time it takes longer than average. And so projects always take longer than you thought because you have all these dependencies.
Well, look at it this way. I mean, especially with events. With events, your deadlines are usually based around the actual event, which does help. So you can't really move the dates once you've started. But things like marketing deadlines need to be in there. You need to make sure you hit these, because you don't hit them, then you don't sell your tickets and blah blah blah. But one thing I will say, it's very rare that on any kind of project manager you go, "We finished early." We finished early and we're under budget.
It's weird, isn't it? Because no, it is weird, but there's the odd thing where that does seem to happen, but definitely not with James Webb. It's obviously they had some massive problems on the way. But going sort of back, so you've got 3 flagship space observatories that they want to build. They've realised that this, that's a massive thing that they want to basically saying, this is what we recommend. If we want to do the things that we're talking about, we want to follow these themes. If we want to find these exoplanets, if we want to find our place in the universe, that's one thing they're saying. But they're also saying that the US has to sort of catch up with Europe when it comes to ground-based telescopes as well.
Right.
So the Europeans are obviously building their massive telescope, I think it's the Very Large Telescope, isn't it?
Very large.
Oh, no, the extremely large telescope.
Extremely large, very large is just tiny now compared to...
the VLT is just, that's already done. The extremely large telescope in Chile by Europe, and that will probably be finished in 2028.
Yeah.
But the Americans are trying to build the Giant Magellan Telescope and the 30-meter telescope, which are kind of their equivalents.
The 30-meter telescope. They're not going big on imagination, are they, with these names?
The 30-meter telescope. Well, it's the TMT. That's the one has had all sorts of issues because of indigenous people in Hawaii, and Mauna Kea, and them saying you can't just build this massive thing up here, and it's being blocked. And you've got different sites, but they're finding it very hard to get the planning permission to get one of these things. And of course, the Giant Magellan Telescope and 30-meter telescope are kind of rivals. But what they're suggesting in this report is like, come on, we need to team up, because those two telescopes together would actually cover such an enormous area of the sky, both the northern and the southern hemispheres. In other words, the whole lot. Yeah. Which the Europeans can't do. So they're talking about, how do we, get ahead of the Europeans here? And so they're basically proposing that they get involved and actually add some funding in and try and get this done.
Right. But so do you think they'll work together?
Yeah, well, hopefully. I mean, hopefully that they'll get some. They'll put the money in, and these things will get built. But it's hard to overestimate or hard to oversell just what these giant telescopes will do for astronomy. But they'll be able to do things that are just simply not possible in any other way. So this is it's big. It's big.
It's giant.
Yeah. But it's like one of the things, I love this quote in there, that it's like one of the things that they're trying to sort out is life out there in the universe. Life on Earth may be the result of common processes, or it may require such an unusual set of circumstances that we're the only living beings within our part of the galaxy, or even the universe. Either answer is profound. The coming decades will set humanity down a path to determine whether we are alone.
Oh,
So, that's like, so it's, we're really honing in on that question. It's like, let's just get this question done.
it is the big question. That's it. It's the only
really
question.
Is, isn't it? I mean, but you've got to admit that, that's a very exciting time to be alive, where they're really taking it very, very seriously, that we actually are on the edge of being able to answer that question. Are we alone in the universe? It's like there's been no other human alive in our, in the history of mankind, not even Edmund Halley or Isaac Newton, are coming close to answering that question. And yet here we stand on the precipice of it, Chris.
It's great privilege.
Exciting?
It's a great privilege. Without a doubt.
And the other thing that's worth noting about this report is that they raise the issue of systemic racism and sexism within the astronomy community, and basically, and rightly so, saying that that's weakening the quality of science. And it's obvious, isn't it? The more diversity you have, diversity of thought equals better thought.
Absolutely.
So that it's quite good that they've well, more than quite good. It's probably essential that they've pointed that out, that they need to do something about that. Let's hope they go about it in the right way. It's quite a complicated issue, isn't it?
It's a big start, and I'm seeing change with a lot of companies, and a lot of organisations are doing this. So it's making real change as well. And we're only gonna all benefit from it.
Yeah.
As I said, the equal rights don't take away from your rights. It's not pie.
Yeah, so I mean, the thrust of the thing is, look, astrophysics is done by humans. And Jane Rigby put it the best. She said, how these humans treat each other, how they are led, how they hold each other accountable, what the policies and the systems that they're working in. This makes so much of a difference to the quality of the science that gets done.
Absolutely.
Boom. So, once again, science leads the world in progressive thinking.
Yes, absolutely.
There's a few other things in there. They do sort of encourage these medium projects as well, and saying we should get probes out there that are looking for out there looking for X-rays and those kind of things, far infrared missions that are cheap, that also complement what the European Space Agency are doing as well. So they were looking at, I think, European agencies, Athena mission was one of them, and they're trying to sort of match that and sort of saying, this would be a good, we should build the cheaper missions to complement what they're doing over there, and make sure that we send out these probes and do all this kind of stuff, and also concentrate on gravitational wave interferometers and stuff like that, and build the next LIGO and upgrade the LIGO and prepare for the next big LIGO.
Do you think if they do the next LIGO, they'll finish it and then they'll switch it on, like, and literally that day they'll detect gravitational waves like they did with LIGO? That was the best thing, wasn't it? It was like, we was like, oh yeah, just switch it on. Oh, we've had one.
There we go.
That's great. Absolutely amazing.
Yeah.
It could have happened now or in a billion years, but it happened just now as we switched it on.
Yeah, I mean, I really love the idea of these space-based gravitational wave interferometers.
Yeah, amazing.
ELISA, the Europeans are sort of trying to build. I mean, that's going to be absolutely amazing. But anyway, so that is the decadal review, and I'm sure that's going to be unpicked over the next few months and looked at, and where the money's going to come from, because there's an awful lot of money in there.
Yeah.
One sad thing
stuff
that I noticed is that they were sort of saying that, do you know Sophia, the Stratospheric Observatory for Infrared Astronomy, and which is the telescope that's on a 747?
I do now.
It's a sort of telescope that's on a 747.
Yeah, I think I've seen that, yeah.
Apparently it's very expensive to run.
Yeah.
And it hasn't had and it doesn't actually do that much science compared to, say, Hubble. which is about the same cost to run. So
Wow.
it's so it's one of those ones where it's like you should probably put the nail in this project now and concentrate on other things. So it's not all good news for everyone. But there we go.
But I mean, the 747's getting a bit old as well, isn't it? So
yeah, do you know, it's amazing, isn't it? The 747's still around.
yeah.
Well, but there we go. But it's still there. People are still using it.
Yeah, it's still
With
going.
the A3800. But anyway, poor old Boeing. They need something.
Yeah.
I thought, so there was that, and I thought that was really interesting. And a kind of on a related note, I noticed that a few weeks ago we had Orb 2 on, which was basically a sort of commercial version of the ISS. In other words, a space station, a way of building a space station. Now, the problem is the space station looks like it's probably good till about 2028 or 2030.
Yeah.
But if it's really going to be decommissioned about then, we really need to start thinking about what's replacing it now in a hurry, because it's going to take longer than 5 years to kind of sort that out.
Yeah, definitely.
So something that has started, there's been a lot of movement on this in the last couple of weeks, and that's people have actually started to enter into this space of a commercial space station. And of course, the last thing that that NASA and America want is there to be a gap between their activities in low Earth orbit.
Definitely.
A bit like, I guess, the embarrassing gap of Space Shuttle to Dragon, where they couldn't get astronauts up to the space station, is bad enough. But not having a space station at all, while the Chinese have one, would be just too embarrassing.
Yeah. Yeah, completely.
So a load of big companies have just bunged their hat in the ring. We knew about Axiom Space. So Axiom Space have always had this kind of space station that they want to start launching these modules up to the International Space Station to form part of the International Space Station. And they've got some major cred, because Charles Bolden, for example, who's a former NASA administrator, is one of the companies, is on board. He's one of the employees of the company. So it's not like they're a clown shoes outfit or anything.
Right.
So, they want to build these modules. And as part of that, they'll have this sort of working modules on the ISS. And when the ISS is decommissioned, this thing will sort of break off and become a space station on its own.
Well, that plugs the gap.
And so that will plug the gap. Yeah, so you'll have this new space station that's made up of a space station that was a sort of commercial bit of the ISS. So that, that looks like a fairly feasible plan. What's interesting is the inside was designed by the French architect Philippe Starck. And it's very, very posh habitat with changing colour LEDs, and it's got fast Wi-Fi and video screens and picture walls and massive glass-walled cupolas and things like that.
Well, that sounds great.
Yeah, and they kind of pay for this, because Axiom Mission 1 is one of these Crew Dragon missions that's going to be taking people up to the ISS as commercial missions. So that will, carrying astronauts and members of the public, people from investment companies and stuff like that, up to the International Space Station. That might be the early part of next year that's going to happen. So Axiom are already kind of starting to think about the money and how they get the money for this.
That's great. So they're really thinking about the space as, something where someone wealthy is going to pay to spend time there. So it's not your sort of, clumped together sort of feeling of the current ISS modules, which are very nice and everything, but they're not really thinking about ergonomics and beauty and stuff in there. So it's actually quite a cool way of thinking, to go like, let's make it a nice place to be, because then we get more money.
Yeah, exactly. And of course, they're thinking about the science they can do, and maybe they can attract people who want to do 3D printing in space or research in space. And, that's the whole idea of the International Space Station. And of course, it was just too expensive to have a laboratory in space where the government aren't paying for it. But now they've kind of trailblazed, how to do it. Hopefully the commercial sector can start taking that burden. And that's what, and obviously this must be the case because there's suddenly lots of people have stepped into this space. So next in were Nanoracks, our friends over at Nanoracks, which is a really cool company. They work on the ISS a lot, like launching, doing way more than just launching nanosats and stuff like that. But they're a big space company. They're already up and running, and they're going to collaborate with Voyager Space and Lockheed Martin. Voyager Space, I believe, are the kind of venture capitalists that own Nanoracks. Right. With a boss that's like really obsessed with industrializing space. He thinks that's the next great market, I guess. Okay. And he's probably not wrong. So they're trying to develop this free flying commercial space station called Starlab.
I've heard that before. Surely there's been a Starlab already. No, Skylab.
The Skylab. Starlab's just one better, isn't it?
Yeah, basically.
Starlab. Yeah, it is a bit disappointing about the names of these things, but hey, it's Starlab. It'll do.
Yeah.
So Nanoracks are going to lead this project, despite the fact that Lockheed Martin are obviously seriously loads bigger. But I think it's down to their leadership when it comes to the way that they've been commercializing the ISS. But Lockheed Martin are obviously pretty good at building stuff.
Yeah, they've got a good track record.
Got a very good track record at that. So they're going to be building it, and so that should be really interesting. And then, last but not least, you had your old Jeff Bezos, Jeffrey, announced at the IAC in Dubai that Sierra Space and Blue Origin were combining to build the Orbital Reef. So yes, that was revealed. Preliminary plans on the 25th of October.
That sounds very nice. Orbital Reef.
Yeah. The Orbital Reef. Yeah, that's a better name, isn't it? Somehow.
Is it reef or wreath? Are we thinking like a wreath that you put on a door, or a reef like a coral?
Like a coral reef.
Okay, good. Okay.
Yeah. I think that's better, isn't it? I wouldn't want to be on an orbital wreath.
No.
It sort of has a kind of death wish attached to it.
Sure, and they're only seasonal as well, so...
Yeah. Well, just all sorts of negative connotations. I suppose Christmas wreath. I don't know.
I was thinking Christmas wreath. You were thinking death wreath.
Yeah. I don't know why. I've definitely got that in my head. So that's designed for 10 people.
Right.
Starlab, I think, is just designed for 1 or 2 or 3 people. They want it to be continually hosted, but up to 4 astronauts, whereas this is up to 10. So that you're talking about a big old thing. And you've got Blue Origin, who are going to be building these large diameter modules that, of course, can be taken up by their New Glenn very large fairing launch vehicle. You've got Sierra Space, who make the Dream Chaser.
Now that's a great name.
Yeah, the Dream Chaser is still my favourite name of all the yet to be built space modules.
Yeah, that's
so that's their little space plane that can take crew and cargo up to the International Space Station. Now, the advantage, of course, it not being like a Dragon capsule, is that it can land anywhere in the world. So you can get your science back to a runway of your choice and say, right, let's get it back to this runway because that's where we're going to pick it up and do the science.
Great.
Very good. And you might want to get your people down to a runway as well. It's quite good. So Sierra Space are supplying the some of the modules, and this means of getting to and fro. Boeing are apparently involved as well, using their Starliner crew spacecraft to get up there and providing some service modules. And there's a few other companies, Redwire Space, Genesis, and Arizona State University, also involved. So it's heating up the race to replace.
The race to replace. I love it.
The race to replace a place in space.
The race to replace our place in space.
Place in space.
That is wonderful. Wonderful poetry.
Is heating up. So that's good, isn't it? That's it, really. I just wanted to point out Matthias Maurer, who we interviewed a few months ago, myself and Julio. One of one of the nicest and humblest and greatest people I've ever met. Should be going to the International Space Station this week. He's been delayed because of a few issues like weather, a little bit of illness, and now they've decided to get Crew 2 back before they launch Crew 3. So that's happening today, I think. You should see the return of Crew 2 splashing down. And once they've done that, they're going to send up this Crew 3 Dragon up to the International Space Station.
So they just held them back. They held them back while the others come back.
Yeah, there's we got to do a swap. Let's not make it really complicated.
Yeah.
Let's just get that lot down and then this lot up. Let's just do it.
Good shout.
There's a few things to notice. There's Rajachari, Thomas Marshburn, of course, Matthias Mara, who are on this flight. But one of the seats was held back because it was supposed to be for a Russian cosmonaut, as America and Russia kept swapping seats on various launch vehicles as, ways of keeping each other happy.
Yeah.
But Russia haven't got their act together, and so it's actually been assigned to Kayla Barron. So that's the fourth person going up on Expedition 6667.
Cool.
So they got to name the capsule as well, which is the first time, I believe. I think it's the first time rookie astronauts are flying on a Crew Dragon that's new itself.
Wow.
So that everything is new. It's all. Everyone hasn't been to space before, not even the capsule.
Including the capsule, that's great.
So it's a complete rookie flight.
Yeah.
It was named Endurance, which I have to say is a little bit boring. I can't help feeling that spacecraft have been called Endurance before. Yeah. It's very American. It's a very American name, Endurance.
But they could have called it Rookie. And everyone went, yeah, that's great. That's a really good idea.
Yeah, the rookie.
Endurance just doesn't seem to. It doesn't say anything about the mission for me.
No, it's apparently a nod to the endurance that everyone had building it through the pandemic.
Oh, blah blah blah.
and a nod to Shackleton's ship Endurance.
Okay.
Well, which one? Which one is it?
Yeah,
it's a little bit. I think that's a little bit disappointing. I do like Matthias Mara's. European name of the mission is Cosmic Kiss.
Mwah. Beautiful.
It's a good name. There's something very cute about it.
Yeah.
Although, I suspect as a teenager you had a Cosmic Kiss, didn't you?
Oh, I had a few, yeah.
In some Liverpool nightclub.
God, that was cosmic. Let's do it again.
Yes. So yes, that's it. That's the Interplanetary podcast this week. Have you got up to anything this week?
Well, I did have a story. So the Americans are obviously keeping an eye on what China's doing as always, and so China's Shijian 21 debris mitigation satellite has got another object orbiting alongside it, and we don't know where it is. So I like that. I like that little bit of news. But other than that, I'm just keeping busy. I'm off to London. I'm going to be Major Tom tomorrow, so I don't do that as often anymore. So I'm quite fun pretending to be a astronaut trainer for the day with some primary school children. It's nice to be primed by a bit of space news actually, because I can reel some of that off tomorrow and say that I thought of it.
Oh yeah, and you could even play them a little snippet of Matthias Mara on the Interplanetary podcast and say, I do this podcast and here's someone going to space this week.
Yeah, I might do that. And you know what? Also just recruit new listeners for the podcast as well. Whenever I'm working.
Exactly.
What about you?
I love it. I should just be working. Am I doing anything? I'm not really doing anything exciting this week, I have to say. I'm just getting my head down, getting back into recording a few Queen covers to catch up on my other podcast.
Awesome.
The Recovering Queen podcast. But yes, I'm just back at it, Chris, as well you know. Doing a lot of music stuff. But yeah, it's really interesting. I'm definitely going to read more about the Astro 2020 because I think it's, if you get your head around that, you can kind of see how space is going to shape up for the next 10 or 20 years. I love it.
Sweet, yeah, I like that. I was speaking of remember ages ago I said I was going to do a movie podcast, and I kind of did a pilot and it never quite got off the ground and blah blah blah. Anyway, I've found a new home for it, and I'm going to be rolling that out in the next few weeks. It's going to be actually a radio show. So,
wow, cool.
Yeah, I was really really excited about it. I haven't got dates and everything yet, but next time I'm on, I'll probably know more about it.
Oh yeah, well definitely let us know. Definitely let us know. I think we should let the Spodcats go now.
Okay, yeah, let's let them go. Bye, bye, Spodcats. Bye, Spodcats. Bye, Spodcats. Bye, Spodcats. Bye, Spodcats.